Welcome to the first episode of the Connected Engineering Podcast. And today we have a very special guest, Moritz Maier, co-founder and co-CEO of Synera. Welcome to the show.
Thank you very much, Josef. Glad to be here.
Amazing. Can you give us a quick introduction? Who is Moritz in the first place? What are you guys doing?
Yeah, well, I'm Moritz. I'm one of the founders and managing directors of Synera. I have an engineering background, so I studied aerospace engineering down the past in Stuttgart, south of Germany. And there was like a lesson, one of the latest lessons in the studies. It was around biomimetics. So like I coming from the nature and its solutions and trying to convert them to the technical world. And this was totally fascinating for me down the time. So I decided to do my PhD in the area of product development processes. So I really deep dived into the way how engineers are developing physical objects, the classical V models or the model-based system engineering approach. So I really dig deep into this area and finally came to the conclusion that actually there should be a better way to do so because lots of inefficiencies in this way forward. And so in 2018, actually, we founded a company, a startup that actually tackles this problem, how to develop better products faster. And now here we are with our first podcast. It's amazing.
Definitely. You used to be called Elise, but now it's called Synera. Maybe I think this is also kind of a hint on what you guys are actually doing. So what does Synera mean in the first place?
Absolutely. So Synera is actually a word that consists of two areas. The first one, syn, comes from synergies and coming from working together. So what we analyzed during our time as engineering service providers is that the engineers, if they want to solve a task, let's say develop a car, they have to work together with different software tools, but also different people among different departments. So it's all about using this connectivity among tools, among departments, among people, and to use synergies. And so what we try to do with Synera is actually bring this together to have a synergy of all of these different aspects. And the second word actually is the era. And this comes from a new time, a new era where actually the engineers work together in synergy. And so if you combine it together, that's where our company name stands for, transition into a world where actually engineers can work together using synergies among tools across departments, actually to speed up development.
Yeah, it makes a lot of sense. What I really like about your mission statement is kind of you are convinced that every engineer can do great things. So literally every engineer. And you do that by empowering them with a visual programming language. So how does that work in the first place?
Yeah, so this is really like our heartfelt mission, because if you look into what actually is necessary to automate product development, at some point you don't come around writing scripts or macros and these kind of stuff, because the complexity of actually like bringing physical objects to life, it's huge. And at some point, we felt always in our projects, we should have learned some Python skills, or we should have learned scripting and macro writing. And I think some of engineers are able to do so. If you are like a very skilled person, you can come up with your own macros, your own automation scripts. And we typically see this in the simulation departments where you're handling with, let's say, finite element DAGs and these kind of stuff. But the majority of the engineers, they cannot program. And so actually they're lacking the ability to, for example, use AI scripts or macro or automations. And so we had the idea of actually like also enabling them to come up with this full automated product development process. And the easiest way to, on the one hand, handle the complexity of the engineering tasks, but on the other hand, enabling somebody and not to write code, there's like this very sweet spot in the middle, which we call low code, or in the end, visual programming, where you can somehow create code, but with a very easy to use visual editor, where you just click nodes and wire them up to workflows, as we call them. And in the end, it's nothing else like programming, but it's way easier. And so I think we have found a very, very sweet spot to leverage the programming skills also for people who cannot write code.
I think it makes sense. And everyone who wants to try it out, we put a link down in the description of the podcast.
Absolutely.
So people can actually check it out for, I think, 14 days, free trial. So people can actually see how it works in action, connecting their own tools, maybe how to integrate it into their own workflows. I think what's interesting is, or maybe a question would be, what was the initial spark where you decided, okay, we see a problem in the industry and we decide to actually create something like Synera or build a tool such as Synera? What was the initial idea coming from?
So we got inspired by the architects, actually. So the architects are using tools like, for example, Grasshopper, also some kind of visual programming tool to come up with they call it generative design. So all these patterns that you actually see in this architectural world, for example, from the Zahat Ardit architects in Dubai, they look super stunning, and they're like super complex at the same time. So there's no pattern inside that you can just use with a X and Y pattern in CATIA, for example. So what the architects and designers actually have come up with is leveraging those visual programming tools for this complexity and geometry generation. And this was the idea, actually, of us. Is it possible to also use this for other domains in engineering, for simulation domain, for cost engineering domain, for whatever manufacturing simulation domain? And I guess this was the initial idea. So we identified a very cool technology which was focused only on geometry. We tried to, let's say, bring it out to all of the other skills that engineers need to actually do product development. And it turned out in the end that it's possible, that it's really like we are now able to program physics simulation, or we are able to visually program cost engineering workflows. And this is pretty cool, because if you bring those worlds together, like geometry generation and, for example, physics simulation, you can run optimization loops over both domains. And, for example, ask the question to an algorithm, oh, what is the best design if you take into account a minimum wall thickness of X and maybe a maximum stress strain of Y? And then the algorithm is able to answer this question. So we are close to our vision, actually, to have a assistant at the hand of an engineer.
And hopefully in a couple of years, Jarvis. So if anyone knows Jarvis in the podcast.
Yeah, absolutely. Absolutely. So if you look into our logo of the company, it somehow reminds you maybe of this nice Tony Stark light. I guess it's a battery of his super suit. Yeah.
Exactly. I want to put emphasis on maybe two industries or trends. You mentioned cost engineering and also maybe e-mobility. So let's maybe take two use cases. Let's say battery pack design or cable routing from the e-mobility side of things, but also cost engineering. Maybe we can start with cost engineering. What is the added value there using Synera?
So in every domain that we're looking in the engineering world, actually, we come to the situation that most of the time, the people who are trying to solve solutions, and so also for cost engineering, have to use a multi-tool stack environment. So in cost engineering, it's typically lots of Excel lists, some proprietary Python code, for example. There is cost engineering software like Siemens Teamcenter, PCM, or Facton, or a priori. So there's lots of specified software for actually solving this task of predicting a price or calculating a price. And usually what the engineers are doing is they're like manually entering input data in one tool, then getting it simulated, and then exporting the data, and then coming to the next tool. And so it's like a chain. And this is very similar for cost engineering, but also for piping or cable routing. On cable routing, it's a different tool stack, of course. So maybe you want to have some pressure drop calculations in there, or path finding algorithms, piping algorithms. But in the end, it's always you need to wire up or automate different tools who are specified for solving a specific task. And there we come in. So actually, if you look in a visual programming language like Synera, you can think about like an automation meta layer on top of the existing software tools. And for cost engineering, the easiest process actually is, for example, to extract CAD data from the PLM world, like do some CAD operations on the geometry, whether, for example, count the holes or the bending beams or the welding lines, anything that you can like extract out of the geometry, then use this information to feed for example, a tooling calculation software where you can like get out the tooling costs, then use this, for example, for accessing a web service which can predict the CO2 footprint, for example, and then all get a summary and push it back to the user. And that's pretty cool because you can speed up things, and this directly has an impact on, for example, very strategic decisions based on the purchasing department. But also, this definitely helps to democratize the knowledge. So if you think about, for example, that you can store your ideas or your decision making inside of a visual programming workflow, you can copy paste it to your colleagues. And so this is pretty cool that you can like use your expert knowledge and spread it along the whole company.
Yeah, that makes a lot of sense. I actually wanted to talk about this democratization aspect and also like collaboration aspect, because some of the colleagues might be use case or domain agnostic. They have no idea what's going on, but maybe you can communicate what you want to say with a visual programming language. And there's something also called Synera Run. So where does this fall into place when we talk about democratization?
That's a good point. So actually what we realized is that there are, like say, process experts in companies who are able to model these workflows, like come up to the logic, how to do a topology optimization, for example, or how to run a CAD analysis. And these experts, they're usually like a small group in the company. But there is a huge group of people who actually have interest in the results of these groups, right? So if you think about a company like, I don't know, Mercedes or BMW, they might have thousands of engineers, but only, let's say, 4 or 5 CFD experts in a specific department. So our idea is actually, how do we get the expert knowledge from these experts spread off to the whole company, that everybody can use it? And what we realized is actually that most of the, let's call it managers, or who are interested in the engineering knowledge, can work with the engineering knowledge on a input and output basis. So they want to input their question, let's say, for example, a part number or a specific load case, and they are interested in the cost or the maximum stress, for example. And they don't necessarily need to know all the details in the black box itself. So what we have come up with in Synera Run is actually a possibility to convert a very complex workflow into a very simple input-output user interface. And you can just use this in a website, you can send it to your colleagues, and you can say, here, if you want to know the costs of your part, just put in the geometry and maybe the amount of parts that you want to calculate, and in a couple of seconds, you get the price estimation back. Of course, this is like very, very interesting, and it helps to scale, but it's also very, very, let's say, you have to know what to do. Yeah? You need to really make sure that the process which is covered inside of this black box is the right one, does produce the right results, because you can like spread also wrong information very easily in the company.
Yeah, definitely. I maybe want to talk, or maybe spend a couple of minutes on the black box aspect. And when we use visual program, let's say you have AI features, machine learning features inside, how much is black box and how much of it is a white box? So how can I go into it? It's basically, maybe we can compare it with Simulink a bit, because in Simulink you can also kind of group specific modules into kind of summarize it and then open it again by double clicking on it, and then you see what's behind all of it. This is also how Synera kind of works in a nutshell, basically, if you want to summarize it like that.
Yeah, I guess you can draw the parallels here as well, like in some. So actually, we're calling it nested workflows. So there's like the possibility, if you like have defined the logic, you can group it, and then it becomes a single node. And if you double click on it, you can look into its inside, and you can see, okay, what is the logic actually that processes this node? And you can have nested workflows and nested workflows and nested workflows. So you can really go down the rabbit hole. And we've seen customers are actually like using like over 10,000 of nodes, but group them up to a very, very easy to follow high-level process. So if you think also about what, for example, model-based systems engineering is doing, where you come from the very like high-level view of a whole system on the first layer, then you can go down to the second layer, maybe where you design your parts and your groups. Then you can go down one layer further where you design your like specific single parts or screws or stuff like that. And so you can really like build up a whole complex system with the same logic, and you still have the easiness to understand the process and also the details. So there's no black box inside. You always can like look into under the hood if you want it. Sometimes you don't want that people look under the hood. So for example, if you share a workflow with a partner, with an engineering service provider, for example, maybe you only want to have them using the process, but don't get an idea about the IP that you protected inside of the workflow. So we came up with the idea of course, password protection and encryption. It's kind of similar like if you're doing a simulation material data for highly expensive physics simulation, for example. There's also this kind of, I want to enable other people to use my model, but I don't want to like publish all the knowledge how I came to this model.
Definitely. I think one thing we also have to talk about is the so-called add-ins. So people have the possibility to use or access other software if they want to. Maybe we can talk a little bit about what the benefit of this is and how it facilitates engineering workflows in general.
Absolutely. So we deeply believe that engineers should use the tools that they are best made for of a specific need. So for example, if you take, let's say, Abacus, for example, as a very, very good non-linear simulation solver, or if you're using LS-DYNA for explicit crash dynamics, or if you want to use CATIA for CAD generation, all of these tools, they are very, very specified for a single purpose, and they are best in. So I tend to draw the analogy of us being more the Android system. So Synera itself is a very open platform, and we enable our customers to connect all of their existing software tools to our platform. And once they are connected, there's a marketplace. So you can just like download, for example, the ANSA connector or the HyperMesh connector, and then you can use HyperMesh or ANSA to do your meshing, your preprocessing. And so, of course, you can think of the ecosystem of software tools in engineering is huge. There's thousands of different software tools. So we try to somehow enable the customers to do the cherry picking. So on Monday, maybe they want to do a meshing with HyperMesh, and on Tuesday, they want to do a meshing with ANSA and Abacus simulation. So we thought about also from a license perspective, how actually could we enable them to do so? Because actually as an engineer, I don't want to be focus and bound to only use the salt systems. Why? And so we came up with a token system. So this is kind of like a virtual currency system that you can just like rent from us. And with this system, you can access all the add-ins, all the tools that you want to connect to that are inside of our ecosystem. And this is a real beauty, and we get really good feedback that this, let's say, all-you-can-eat restaurant is really highly valuable from our end users.
Definitely. I think it makes sense. And also, everyone listening to this podcast, I think they should actually try Synera in the first place, because it's very hard to explain for their specific use case or pain points how Synera works. But I would call it kind of use case agnostic. So you could do a ton of stuff. And I think we don't have enough time to mention all the possibilities and capabilities of Synera. One thing, Moritz, that you mentioned is kind of developing processes rather than developing the part itself. And I think you draw parallels here from software engineering. Maybe you can let us know where that idea came from on actually developing the process rather than developing the part or the assembly in the first place.
Absolutely. So let's take the status quo, for example, and imagine you want to develop an A-pillar for car. What your engineers typically would do, they would like sketch and draw the geometry in a CAD system, and then they would save this CAD file, put it over to the simulation world, they simulate it, get the stress reports back, and then store all of these files inside of a PLM system. The next time actually that they get the task to design a A-pillar, they most likely will start from scratch again, because the files, let's say the geometry and also the simulation, were only designed specifically for this single case. Sometimes they're using parametric design, but this is somehow limited. So it's very, let's say, part-focused development. And the difference is if you are visually programming the way how you come to an A-pillar, for example, you would perhaps start with a rule that might be like, okay, let's do a topology optimization to identify the perfect load path inside of the design space of the A-pillar. Afterwards, please reduce the load path to splines and then make ribs out of it. And then, for example, crusted ribs with the outer shell. And so you would actually define the manual tasks that you would rather do, but they are somehow independent of the actual A-pillar part. So the next time where actually somebody comes to you and will ask you, well, can you do an A-pillar design? You can say, well, yeah, here I have a rule book, I have a workflow which is able to develop A-pillars. And you don't care about the design space or the loads or the different properties, for example, of the A-pillar. It's just an A-pillar design workflow. And this is the real beauty, that you can reuse the workflow. And typically our customers say they can use up to 80% of the code that they have programmed in similar projects later, even if the geometry or the cars, or it's completely different. But the steps how to design an A-pillar, they are somehow similar. And I guess this is something which we see in software development all the time. To give you an example, login function, right? If you want to have a login function, you can use it for your website, for your Microsoft Teams office, for whatever. It's just like a login function. And so with Synera, we somehow come, as we are more or less also software programmers now, to the point where we can create functions for specific tasks. We call this workflows, not functions, but it's kind of the similar. And this is really awesome, because you can just copy paste things. And maybe if you get the task, okay, let's design a maybe a B pillar. you can copy, for example, the topology optimization workflow from the A pillar and adopt the rest to a new environment. So you can recycle parts of a workflow like you do actually if you're in a software programming world. So we're coming to the point where companies can do hardware programming on a continuous improvement of their code base. So they never have to start from scratch again. They can work with the existing code base and improve or adopt. And this is a game changer in hardware development.
Absolutely. When you talk about workflows, I mean, engineers are very inquisitive people, smart people. But when we look at the innovation adoption curve, they're usually in the laggard area. So they kind of don't want to change a running system. So how would you convince people, engineers, or maybe C-level, let's say executives, to actually start using Synera? Because they might be afraid of, okay, I'm going to change my workflow. I'm going to disrupt it somehow. So how does Synera fit into an existing workflow and augment it rather than disrupt it?
Yep. Definitely. I mean, we're changing the way people work here. So this is always difficult and you have to carefully moderate and educate here. But for me, the easiest way to explain it is, for example, that we are using the same tools in the end. So if your current development is done with, let's say, Nastran as a simulation to evaluate the stresses, we are only automating the Nastran simulation deck. So the results that we produce are 100% the same. We can just do it more automatically and faster, therefore. So the return on invest actually is instantly there because it's just like automating the stuff that you would manually do. And of course, usually the question arises that, oh, will I lose my job? That's the obvious question here. But all of our customers so far who have tried it actually come to us and say, well, now I have time to actually be an engineer again, and I get rid of these repetitive tasks. I hated to write stress reports in the past. Now this could be automated by the software, and I can sit down with my colleagues and argue about different manufacturing techniques, for example. I never had time to really think about fundamentally changing designs. Now I have this time again, and this is something, I guess, which highly motivates engineers to work like this. They get rid of the tasks that don't make fun, and they get freed up the time for actually being engineers again. And I guess that's a good thing for everybody.
100%. I think with that, we can wrap up the first episode of the podcast, because we also want to interview the other founders. We don't want to talk about the whole story of Synera, but any closing remarks from you and Moritz, maybe some motivating words to all the engineers out there who want to try Synera.
So I would have loved such a tool when I was in my current studies and also in my former jobs. So I highly can recommend to just try it out. I guess it's easy, explainable once you have it on your desk, because at the one hand, it's super complex. You can do lots of stuff with it, but we try to really nail down academy, guided onboarding and on-demand learning. So there's a whole learning system around it. It's free to use for students. It's super free all time. Just give it a try. If you have some feedback to us, this would be really cool to get your initial impression on it. If you like it, if you don't like it, what we can improve. And I'm really looking forward to this podcast and all the insights that we gather. And feel free to reach out to me as well. So my email address is moritz.maier with AIER @synera.io. Give me a call or drop me a line. I'm happy to answer your questions.
Amazing, Moritz. Thank you so much for being the first guest on the Connected Engineering podcast. And hopefully see you in episode, 20, 25 or 30 again. Let's see.
Absolutely. Thanks, Yusuf, for having me.
Thank you.